Now that we have done the revision questions related to the design of reinforced concrete beam, reinforced concrete slab, and reinforced concrete staircase. These are the topics covered in the reinforced concrete design 1. Now the design covers the analysis of the load, design for the ultimate limit state, particularly the moment and shear, checking for the serviceability requirements such as the maximum and minimum bar areas, minimum bar spacing, allowable deflections, and etc. And also the detailings of the structural elements. We have shown the detailings for the beam, detailings for the slab, as well as the detailing for the staircase. Normally, once you go through the revisions questions, you are encouraged to study and observe through the example questions. If you look into the details in terms of the calculation steps, you will notice that there are certain calculation steps have been repeatedly used in more than one type of structural element. For example, the equations to calculate for the moment. If you look at the revision questions, these equations has been used in the beam, in the slab, and then in the staircase. You also notice that even though all the structural members require the design for the shear reinforcement, however, the equation set used in the beam differ from those used in the slab and also the staircase. Not only that, for the serviceability requirement, some are checked in the beam but not checked in the slab and the staircase. We mentioned that due to the different conditions, the critical serviceability requirement may differ. Of course, you can choose to check all the serviceability requirement for every single structural element, but some are obviously not critical and not likely. Even though you check, it will pass anyway. Therefore, you don't have to check them every single item. In terms of the analysis of the beam adopt the table 3.15 of British Standard 110, whereas the analysis of the slab uses table 3.14 and 3.15 in DBS at 110, but they are not applied in this staircase. To make it simple, when you see the design of various structural elements, the requirements and the conditions vary slightly. There are common steps and there are unique steps. I believe these are the things that you need to pay attention, especially when you are doing the revisions. You need to know for sure the functions of certain calculation steps and their equations, and why are they so. This brings to the purpose of this video, helping you to sort out these three types of structural element as observed from the revisions questions that we have discussed previously. It may not be thorough enough to cover all the design aspects of each structural element, but it is good enough for you to find out their common steps and unique steps. Definitely you need to get all this sorted out before entering your final exam. Without further ado, let us get started. You may refer to this table here. We have the design of beam, slab, and the staircase. Each type of structural elements have their own unique step, but there are also common steps. We shall go through them one by one. First, let us deal with the analysis. Normally in the final exam, you will have to analyze the load, the moment and shear, before you can proceed with the design. Analysis is a part of the design. Normally, it will be assessed in the final exam. For the analysis of the beam, normally we'll analyze the load coming from the slab. You may use table 3.15 in British Standard at 110 in order to estimate the distributions of the area loading acting onto the slab. The loading shall be distributed to certain ratios towards the adjacent beam supporting the slabs. Depending on the beams that you are designing, you will need to get the right shear coefficients for you to estimate the UDL acting onto the beam. Remember, when you analyze the loading acting onto the beam, you need to consider the UDL coming from the slabs adjacent to the beam. Use the relevant shear coefficients and use the equations given in the British Standard at 110. You acquire the UDL obtained from the slabs. Don't forget to calculate the weight of the brick wall and also the weight of the beam. The weight of the brick wall and the weight of the beams are permanent loads. Therefore, they shall be classified under GK. And for the design load, you are talking about 1.35 GK plus 1.5 QK. And then you need to get the moment acting onto the beam. One of the method used, it would be by moment distributions method. This can be done by creating a table, finding the stiffness, distributions factors, fixed end moment, and carry over the moment until it reaches to a static equilibrium state for you to determine the moment acting on the support. Based on the moment generated onto the support, use the principle of static equilibrium. Find the reactions. The reactions to that particular stretch of beam shall be considered as the shear force. And from the shear force that you have acquired, you are able to obtain the shear force diagram. Then, based on the shear force diagram, you obtain your bending moment diagram, particularly for you to acquire the mid-span moment. The moment distributions method table here does not provide you the mid-span moment. You will have to calculate the mid-span moment based on the shear force diagram that you have generated. And then while calculating the moments throughout the continuous beam, you may use that to cross-check with the moment at the support, which shall theoretically be in line with the moment that you have calculated from the moment distributions method at the supports. Bear in mind that the moment distribution methods is only one type of approach that you can use to analyze the shear and moment acting onto the beam. There are other methods that can be used to analyze a structure. Let's say for the continuous beam, table 3.5 of British Standard at 110 is also applicable. By adopting the ratios given in the table, you may estimate the shear force and the bending moment acting along the continuous beam. Now, in order for you to apply the table here, you will need to make sure it fits the conditions predetermined by the British Standard. First, the QK must not be greater than GK. The continuous beam needs to have at least 3 span, which is predominantly due to the uniformly distributed load. and the variations in terms of the span length between the maximum and the minimum length shall not exceed 15% of the maximum length. Other than that, you may use the subframe analysis for you to generate the shear and moments of a continuous beam. For more details, you may refer to the previous videos. This is about the load analysis for the beam. As for the design of the slab, you may use table 3.14 to estimate the moment and table 3.15 to get the shear load. Those tables you can get it from British Standard at 110. I believe you have noticed that the calculations of the shear loads for the slab, it will be similar to the calculations of the UDL acting onto the beam. The equations used are the same. Also, you need to know that these two tables here are meant for the two-way slabs. A slab is considered two-way when its Ly per Ls ratio is less than 2.0. Exceeding 2.0, we will assume the slab to be one-way. The meaning of two-way slab is that the loads acting onto the slab are distributed to all four sides of the beams. As for the one-way slab, you will assume half of the loads goes to one side and another half go to the other side. As for the beams at the shorter spans, you will assume not carrying any load. You need to know also the table 3.14 and 3.15 in British Standards is one of the approach for you to estimate the moment and shear. It is not the only method, but it is one of the most common method used to conservatively calculate the moment and shear acting onto the slab. You may also use the U-line method for you to estimate the load acting onto the slab. This can be done using the graphical method. For the slab that you need to design, at each corner you draw a 45-degree line and then draw the line so that they are connected well, and based on the divided areas, you may use those areas for you to estimate the loads taken by the adjacent beam. Let's say for this U-line shapes, you will assume this trapezoid areas is taken by the beam here, whereas the triangle area here is taken by this beam, and so on so far. The U-line method may be applied when you do not have British Standards in hand. You can try it yourself. I believe the calculations using the U-line method, it will be more economical than this. Just that it is more tedious than using the British Standard. Now, if you compare the state of analysis between the beam and the slab, for a continuous beam, you will need to identify the moments acting along the beam. Same goes to the shear force. The loads can be obtained in the longitudinal directions of the beam. However, when come to the slab design, one piece of slab here will have 1, 2, 3 moment at the shorter span, 4, 5, and 6 moment at the longer span. As for the shear load, each beam will have a shear load. Theoretically, you will have to design every single one of them. Same goes to the design for the beam. you will have to design every single one of them. Sometimes if you choose to make it more simplified, you may adopt the largest moment and apply to all. Also, you use the largest shear force and apply to all. This can significantly reduce the step that you need to deal with in the design of the beam, but it's going to consume more materials. The structural element, it will be more costly. Same principles apply to the slab. Theoretically, you have to design every single part of it, but for simplicity in the design and also simplicity for the construction at the construction site, normally we will adopt the most critical moment and the most critical shear and design accordingly, apply to all parts of the slab. This is about the design of the beam and slab. How about the design of the staircase? We may use the formula of FL per 10 for you to estimate the moment acting onto the staircase. You will need to sketch the bending moment diagram. Depending on the support conditions, whether it is end-span or continuous where there are adjacent members. In the case that the support here are continuous, you're going to expect there will be negative moment. The locations of the negative moment will define where you need to provide top reinforcement bar in the slab. The calculations is relatively simple. Whatever the shape of the bending moment diagram indicates that there are negative moment and there are positive moment. Regardless there are negative or positive, a moment of FL per 10 is assumed. So you will need to get the total vertical force acting along the staircase span. Multiply the L and divided by 10, you get the moment. As for the shear load, you will use the principles of static equilibrium to find the reactions supporting the staircase. The reaction shall be considered as the shear loads acting on the staircase. Coming back to this table. To make it simple, the design of the beam for the analysis part. First, you need to determine the UDL based on table 3.15, which is standard at 110. And this table, it will be the same table that you use to determine the shear loads acting on the slab. You are borrowing this concept for you to determine the UDL acting onto the beam. And then, if the member is a continuous member, you use the moment distributions method. The moment distribution methods only give you the support moment, which is the fixed end moments after redistributions, both sides cancelling out each other, and this will become the internal moment to be taken by the continuous beam at the support. Then you will have to design the reinforcement bar strong enough to withstand the internal moment. And then based on the moment calculated from the moment distributions method, use the principles of static equilibrium, determine the shear force diagram. Based on the shear force diagram, you go back and find the mid-span moment. As for the slab, to get the moment, you refer to table 3.14, which is standard at 110. And to get the shear, you refer to table 3.15. And the design of the staircase is relatively simple. You will assume the moment to be equals to FL per 10. For you to get the shear load, you find the reactions based on the static equilibrium. The same principles apply to the beam.